Hi everyone. In this quick tutorial video, I wanted to share with you an alternative method to efficiently model what is commonly referred to as a Merkaba in sacred geometry, or more technically, a stellated octahedron. I've already demonstrated how to create this shape in a previous video using both 3dsmax and Blender. I hate to be redundant with content on my channel, however, I stumbled upon a much faster and easier way to create this same object, specifically in 3ds Max, and I couldn't resist sharing it with you here. So without further delay, let's open up our 3ds Max to an empty scene and get started. All right, the first thing is always, if you're going to output for an STL output for 3D printing, we need to make sure that we're modeling in real world units. All right, so go up to Customize Unit Setup and make sure you're set to metric, and I prefer to use millimeters. All right, and then click on the System Unit Setup and make sure whatever unit you're using out here, you also have selected in here. So in this case, it's millimeters. 1 unit equals 1 millimeter. Click OK and OK again. Now the scene is set up for real-world modeling. Okay, so unlike the previous video, we're going to start off this time with standard primitives and just a regular box. All right, before you drag anything out in the viewport, switch the creation method from box to cube. All right, and I'm going to open up the keyboard entry, and in length, width, and height, just type in 24.0 millimeters. All right, for all 3 parameters, and then just click create, and that'll bring a standard planar box right into the center of the screen here. Okay, and I'm not using any internal segments on the object, as you can see. All right. So the next step is just to go to add an edit poly on top of that. Okay, and we'll drop down into edge mode. And well, before we do that, let's hold down Shift before you drop down into sub-object level. Hold down Shift on the keyboard, and up here in the Graphite Modeling Tools, click the Tessellate button. Okay, and we'll give it a tessellation, not with edge, but with polygon style tessellation. Okay, and that'll create these X's along each of the planar faces of the cube. All right, just click OK. That's the pattern we want. Okay. All right, now with this object, we're going to go down to our edge level. All right, and just go ahead and select one of the X's. It doesn't matter what face it's on, but just go ahead and select one of those X patterns, and then go ahead and select similar to grab all of them. Okay. All right, now we're going to use extrude as a technique to chamfer these edges, and you'll see what I mean in a second here. Hold down Shift on the keyboard and click the extrude tool. All right. Now we're not going to use any height value to the extrusion. All right, we're just going to use the width value. So type in 2.0 millimeters into the width, and then click OK. And you see what this has given us here. All right, now you can feel free to experiment on your own to see what difference the chamfering would have given you on those edges, but rest assured that this is the result we want with the extrusion. It's a equidistant edge extrusion without any height. Okay, chamfer would have given us a much different result, even the quad chamfer. All right, so now that we have this, we can hold down Control on the keyboard over here in the Edit Poly under the Selection rollout, just click Polygon while you're holding down the Alt button, and that'll give you all of the face selections that are associated with those selected edges. All right, invert that selection and delete. And you can see already that we have our Merkaba shape. Okay, of course it's a single-sided object currently, and if we're going to 3D print this, we need to make it a solid. All right, but we're going to do that. We're not going to use shell, and I'll give you an example of why. And I think I may have mentioned this in the previous video, but shell is going to we're not going to get planar edges here on the inside using shell because it extrudes along the normal. And you can see what's going to happen here is we're going to end up with some crossed edges if we want anything, you know, of 3D printed thickness, which is, you know, between 2 and 3 millimeters. It starts to distort. Okay. All right, and that's perfectly normal with the shell tool, and I think that would happen in just about any application. So we're not going to use shell this time because we want nice planar straight edges in here on our extrusion to make it solid. So instead what we're going to do is we're just going to do a duplicate technique. We're going to select the entire element, hold down Shift, and switch to your scale tool, hold down Shift, and scale down a duplicate copy. And I would scale it down to probably around 75%. And release, and it'll ask you if you want to make it a new object or a clone. We want to clone to element, and click OK. All right, so this is what we have so far. Next step, with everything still selected on the new duplicate, we'll go ahead and flip the normals. All right, and that is so that we could switch to border mode, box select everything, and that'll select all the borders on both elements, and click bridge. All right, and that'll give us a nice clean bridge, and you can see the difference now in here. Everything is equidistant and planar. All right, and there's no distortion to the to our solid shape now. Okay. All right, so this is right now this is a low poly solid object. There's no holes in it. So this would be 3D printable. However, we're going to just take it a couple steps further here and add some chamfering to the edges and clean it up a little bit. All right, so one of the things we'll do here is we'll just ring that current selection that we had. All right, and we'll switch to edge mode, and we'll connect that with 2 segments, and we'll give it 90% pinch. Click OK. All right, now with edges still available, go ahead and select one of the edges here on the interior portion here along the border, and then go ahead and ring that selection. All right, and then go up here to your select similar, and that'll grab all of them. All right, and we'll just do another connect, and you could just click it once this time and it'll retain the previous settings. 90% is okay. If you don't want it that tight, then you could change the settings. I'll go back and do that right now. Holding down Shift, click the connect button again, and we'll just change the setting here, the pinch setting to 80% this time, and then click OK. All right, so now we could subdivide. Okay, and you can use Open Subdiv in the newer versions of Max, or go to Old Turbo Smooth will do just fine. And I might give it 2 iterations. Collapse it down. All right, switch it back to editable poly, and there we go. This is now exportable to an STL file, and can be 3D printed. Okay, so I hope you enjoyed this alternate technique to achieving this shape. I think this is a much cleaner, faster way to go about it than the previous way I illustrated in my other video. Let me know how you did with it. All right, and Just so you guys know, I have this model 3D printable available on my Shapeways store. I'll leave a link in the description. Thank you for watching. I hope you found something new here, and I will be back with a new video very soon. Alright, so please like the video and subscribe to the channel, and I'll see you soon. Thanks.